Yesterday I assigned around 10 problems, na? Jivika, collect error list after my class. Okay? Harshit, you too, boys, collect error list. Coming CBT electrical instruments is there, huh? You don't know. I shared na CBT WhatsApp group. I shared na. Is there, huh? Sure, huh? Okay, students. So today our next topic is maximum power transfer theorem. Maximum power transfer theorem. Which one is this? Why you? No, I will put 26. Very chill means you should not turn off my set many times. Put 26. After 10%. Why? What's volume? Okay, so here maximum power transfer theorem. So for any electric device, if you take, under which condition it will dissipate maximum amount of power, right? If you take a electric bulb for producing maximum brightness, it should dissipate a maximum amount of power. For suppose one simple circuit I will take. Let's say this is any electric resistance capital R. This is any cell of EMF E, and its internal resistance is how much? Small r. This is called one cell. If you switch on the cell, what will happen? Current I ampere will flow. So how much current will flow? Can you tell? I is equal to net EMF divided by net internal resistance. So net EMF is nothing but E divided by this capital R and small r in which combination? Series combination. So what net resistance? R plus small r. This is a total current flowing in this ideal cell, and internal resistance and external resistance. Now tell me, what is the voltage drop across external resistance? I'm asking you, what is the voltage drop across external resistance? According to two formulas are there. One is I into capital R, total current flowing, and into total external resistance. I value just now I found. The voltage drop across external resistance I value how much? E into capital R divided by capital R plus small r. The voltage drop across the resistance. And what is the power dissipated across this external resistance? E square. Be careful, that is not a rated power. I am not talking rated power. Power dissipated I am talking. What is the power dissipated? How much? Many formulas are there. According to Joule's law of heating, I square into capital R or VR square by capital R also you can write. Both are correct only. Voltage drop across resistance divided by capital R also I can write. Substitute I value here. So I can write power dissipated across external resistance equal to how much? I value how much? Capital E divided by capital R plus small r and whole power 2n into capital R, and power dissipated across resistance equal to how much? E square into capital R divided by capital R plus small r and whole power 2. Actually, the discussion is about maximum power dissipation. If this resistance is one air conditioner, it should perform maximum output power on the compressor, then only it will cool the room quickly. Now, in case of resistance, if you take an electric bulb, that bulb also should dissipate maximum power, then only it will give the maximum brightness. Yes or no? So means if you observe this equation, the power depending on what factor? One and only one factor, the resistance of that bulb. Why? Because EMF of the cell is always constant and internal resistance is always constant. We will not disturb them. Only one more thing in your hand, by using series combination, parallel combination, you can increase the total resistance and you can decrease the total resistance. So in your max, one concept is there. If y is equal to any equation, y is equal to x square. If you plot any graph where y value is maximum, at the peak value, what is the slope of this tangential line? dy by dx equal to how much? 0. So at a specific value of x here, y value become maximum. So here same concept, here also I am going to apply power dissipated by the resistance depending on the capital R. How? Y depending on x function. Similarly here power also depending on the external resistance function. So when power dissipating maximum, I can write dp by d capital R equal to how much here? 0. Substitute this p value. So what do you get? D by dr and into p value how much? E square by capital R divided by r plus small r whole power 2 equal to 0. So here I can write constants. What I can write? Constants outside small e and okay, so here E square I can take outside. So what you can write? D by dr into how much? Capital R into r plus small r whole power minus 2 equal to how much? 0. This is which rule? U into V rule. Correct? V square I am taking that side. So what will happen? D by dr into r into how much? R plus small r whole power minus p equal to how much here? 0. So this is U into V rule. What is the U into V rule? Product rule. How much? R into D by dr of how much? Capital R plus small r whole power minus 2 plus capital R plus small r whole power minus 2 into dr by dr equal to how much? 0. What is the formula for this? It is similar to x power n formula. What is x power n formula? N into x power n minus 1. Minus 2 into capital R plus small r whole power minus 2 minus 1. And again, this term should be differentiated. And dr by dr equal to 1. And what is the internal resistance differentiation will be? 0 plus and capital R plus small r whole power minus 2 equal to 0. Because dr is getting cancelled out. So minus 2 into r and into capital R plus small r whole power minus 3 plus capital R plus small r whole power minus 3 equal to 0. So minus 2r into capital R plus small r whole power minus 2 into capital R plus small r whole power minus 1 plus capital R plus small r whole power minus 2 equal to 0. This one I can take common and I can send that side. So minus 2 into capital R into this one will be capital R plus R. This is plus 1. If you take that side, it will be minus 1. And minus is getting cancelled out. 2 capital R equal to how much here? R plus small r. R if you bring this side. So this is the condition for the maximum power dissipation theorem. When net external resistance exactly equal to net internal resistance. During the paper discussion also, I told to note down this point. It comes under maximum power dissipation theorem. Means when external resistance exactly equal to internal resistance of the power supply, so there is a maximum power dissipation. This theorem is called what here? Maximum power transfer theorem or maximum power dissipation theorem. You people tell me what is the maximum power dissipated across the electric device? What is maximum power? In the place of capital R, substitute small r. So you will get what? E square into small r and whole divided by how much here? Small r plus r whole power 2. And what is the maximum power equal to? E square into small r whole divided by 4 r whole square. R cancels out. So what is the maximum power? E square by 4r. Okay. So this is the whatever I putting star marks compulsory hereafter. To save your time in your exam hall, compulsory you have to memorize and find the maximum current flowing in the circuit also. For maximum power dissipation, compulsory maximum current should flow. What the maximum current should flow? E divided by capital R plus small r. Na? So put a capital R value small r. So the maximum current will flow how much? E by 2 into capital R, 2 into small r. Sir, all are the possible conditions for the maximum power transfer theorem. So just I have applied for single resistive circuit. It is also can be used in grouping of cells, series grouping, parallel grouping, and mixed grouping also. Same thing will be continued. Okay. Everyone brought materials, huh? Give me one material. No problem is there. Okay, I will go to the next concept. After completing syllabus for the Monday, at a time we'll do all problems. Okay, I searched, but searching waste. No problem. Okay, next one is CR circuit. DC series combination of the capacitor and resistive circuit. So, actually, I told many times, if you look into the capacitor, it will not be used in the direct battery. May I know what is the reason? Tell me, Harshit. Why capacitor cannot be used in DC circuits? Anyone tell? What is the reason capacitor can't be used in the DC circuit? The reason is, after going to house, so there is no time, I am requesting, please revise. It is showing your interest towards your aim. Very simple question. Capacitor last week only I started with this statement only. Huh? Simple answer. Anyone? That is our self-study in your house. I did not ask any neat standard question. Okay, anyway, waste of time. Capacitor will block the current. Once it is fully charged, once maximum charge is accumulated on the either plates, it will not permit the fresh charge which is coming from the cell or battery. That's what capacitors are not supposed to use in the DC circuits. Okay, they are used in the alternating circuits only. What is the meaning of alternating current? The current for which magnitude is changing as well as direction also changing. Sometimes only magnitude changes, sometimes only direction changes, sometimes both changes. Any one of this is called what here? Alternating current. But anyway, you might be noticed, not right now, before 10 years, 15 years, tube lights are there. Nowadays in all houses, this plain LED lights only. So in my generation, in my study, when I was a student, tube lights are there. For every tube light, there is a choke. If you switch on the tube light, immediately it will not glow. Have you noticed? At least, okay, you notice well and good. So the reason is that tube light works under the discharge tube. When suddenly maximum amount of current is entering, the high chances of breaking. That's what, once the charge entered into tube light, initially it will be preserved on the capacitor. Then slowly it will be released to the discharge tube. Then ionization taking place, light will come. So what is the meaning? What is the capacitor job here? The capacitor will not start any activity quickly. Quickest thing is always dangerous only. Correct or not? Okay, that's what the role of the capacitor in any electronic gadget or electric device. It will slows down the increment in the current. It will not allow the rapid increment in the current. That is the only purpose they will use in the DC circuit. Let us see how it will function in the DC circuit, how it slows down the increment in current and how it slows down the accumulation of the charge on the capacitor. So let us see. First of all, simple circuit only I will explain. I am taking one capacitor C and resistance is how much? Capital R. And I connected to one cell. Cell of EMF how much here? E. For simple discussion, I am taking it as an ideal cell. Okay, EMF of the ideal cell is how much? Capital E. And if you switch on it, initially what is the charge on the capacitor? Initially, the charge on the capacitor is how much? 0. Just now I switched on. Here one switch is there. Understood? I closed the switch. So I allowed the current to flow in the circuit. So initially, what is the current in the circuit? Tell me. Think and tell. Initially, I just switched on. What will happen? Initially, the capacitor acting like a pure conductor. So initially, maximum amount of current passing through the resistor. Anyway, what my statement I am going to prove also. For your understanding, I am telling initially, capacitor, what is the role of the capacitor? Respond. Capacitor is acting like a conductor, pure conducting wire. Why pure conducting wire? It does not contain any charges. Any charges accumulated, they are acting like a resistor or opposition. As there is no opposition, the empty conductor, empty capacitor is acting like a pure conductor. By the time maximum current will flow in the circuit. Tell me what is the maximum current flowing in the circuit? Net EMF by net resistance. Understood? So these are the initial conditions. And also, what is the energy stored in the capacitor? As there is no accumulation of the charge, total energy stored how much here? 0 joule. Clear up? Only energy storing in the resistance in the form of the heat only. Continuously it is doing its job with the continuous heat dissipation. Now, this is called initial state. What is the name of the state? Initial state. Now let me explain transient state. What is the meaning of the transient state? Transient means when the capacitor is under charging process. What is the meaning of the transient state? When capacitor during its charging process, then we can tell the capacitor is under the What kind of state? Transient state. Okay. So now we'll interrogate transient state. What is the meaning of the transient state? After t seconds. After how many seconds? T seconds. Next kind of state is what? Transient state. Transient state, what is that? After t seconds. After t seconds, what process is under progress? Charging process is going on. Charging process is going on. Now, if you look into that capacitor, I switched on the circuit. Let's say after t seconds, how the charge will be coming out of the battery? Charge always coming out of the high potential of the cell and it is accumulating here only. So this will be high potential and this will be low potential. I will assume after t seconds, what is the charge on the left plate? C into, sorry, Q I will assume. What is charge I will write? Small q I will write. Naturally, what is charge on this right side plate? I don't need to talk, that is minus q. And this charge is variable. Keep on increasing. As the time is increasing, the q value also keep on increasing. Let's say the current in the circuit after t seconds, how much here? I ampere. Understood? Actually, now my target, how the charge is increasing with respect to time, I have to do. Okay. Now, I want to apply Kirchhoff loop law or junction law. That is my choice. But here loop is there. Advisable principle is loop law or voltage law or mesh law or Kirchhoff second law. So I will assume EMF is how much? E and resistance equal to capital R. Before applying loop law, you have to apply some decoration. This high potential and low potential, and this is low potential. And next one is labeling. I will assume this junction A, this is junction B, this is junction C. How I should walk from? Your choice, A to B and B to C, then finally back to A. A to B, when you are walking, potential is increasing or decreasing? Decreasing. Decrement means in max minus. What is the potential drop across the capacitor? Q by C. Then I am entering from B to C. I to low means what? Minus I into R. Next I am entering from C to A. How I am entering? Low to high means what? Plus E is equal to how much? 0. Okay, so here minus Q by C and minus I value how much here? The current in the circuit, what will happen? This current is nothing but increment in the charge on capacitor in 1 second only. Na? So I have tried plus dq by dt minus dq by dt. Plus dq by dt. Why? Because how much current is coming out of the cell equal to increment in the charge in 1 second. So this point is very important. Plus dq by dt. And into R plus E is equal to how much here? 0. Correct? So this term, how many variables are there? I will round up. Charge on the capacitor alone variable and time is variable. Basic sense of max. One variable should be written left side. One variable should be written on right side. Rest of all quantities are constants only. So this value send that side. What you can write here? E minus Q by C is equal to how much? dq by dt. Okay. So if you simplify this, sorry, R. So if you simplify, if you take the LCM, C into E minus Q by C, perfect, huh? Perfect only, that equal to how much? dq by dt into, here R I am taking this side. Okay. dt I will take that side, this term I will take to denominator. So what will happen? 1 by RC into dt, that equal to how much? 1 by CE minus Q into dq. Understood? If you integrate on either sides, what will happen? Initially, your observation started. Initially, when your observation started, what is charge on the capacitor? Zero. When your experiment completed, after t seconds, the charge on the capacitor equal to small q. Okay. Constants I will take outside, 1 by R into C. What integration of 1 into dt? T. Put the limits from 0 to t. And what integration of 1 by x? How much? Ln of x means C into E minus Q. Okay. And this total term, again, you have to differentiate in the denominator. To differentiate C into E, 0 only, na? To differentiate constant with respect to small q, it will be 0. Understood? And minus d small q by d small q, how much? Minus 1. Correct or not? And put the limits from where to where? 0 to small q here. Correct? So how much that will be? 1 by RC into how much? T minus 0 is equal to this minus 1 I am sending this side. It will be minus 1 by RC. Put upper limit first, then put lower limit. So what do you get? Ln of C minus Q and minus ln of how much? C into E. What is ln A minus ln B? Ln A by B minus P by RC. That equal to how much? Ln. Be careful. This is not log. Log is different, ln is different. When I am talking log means base 10 will come. When I am talking ln means log base C will come. Okay. What is ln of A minus ln of B formula? Ln of A by B. So ln of CE minus Q divided by how much? C into E. Okay. I want to remove ln. What I have to do? Tell me. Okay. So tell me, I want to remove ln. What I should do? Tell me. Apply e power and e power on both sides. Understood? So here ln and base e will be getting cancelled out. And what is the final thing? E power minus T by RC is equal to how much? C into E minus Q divided by C into E. So C into E, take that side. What again at C into E power minus T by RC equal to C into E minus Q. Minus Q I am sending this side. So what I can write? C into E minus C into E power minus T by RC. So what is charge after T seconds? C into E I will take outside. So what I can write? 1 minus E power minus T by RC. This is the most important expression. During the charging process of the capacitor, at any instant T seconds, charge on the capacitor. It is representing exponential increment. Whenever you are watching this term, immediately you have to identify the shape of the graph. Graphical questions will come directly. So if you plot the graph between, this is called exponential increment. If you plot the graph between charge, I am plotting on y-axis, and initially, what is charge on capacitor? 0, and it will rapidly grows like this. After some time, what will happen? After some time, what will happen, friends? Charge on the capacitor, accumulated maximum amount of charge. Hereafter, charge will not grow. What is the name of that state of the capacitor? Very good. Steady state of the capacitor. Once charge is getting maximum, it will not flow. Tell me what is the maximum amount of charge? If you put after a long time, if you put t is equal to how much? Infinity. If you put e power minus infinity. E power minus infinity means 1 by e power plus infinity. E power something power infinity means infinity. 1 by infinity means what? 0. So this total term becomes 0. Understood? So what is the charge on that after a long time? Logically also you can answer this, friends. Always max is not required. Logically speaking, after a very long time, what is the maximum charge on the capacitor? It will be plus C into E here. What the name of that state is called? Steady state. Steady state. And here at one particular time, for suppose after some time R into C. What time? While charging process was going on, after some time R into C, this charge become, if you put T value RC, what will happen? C into E 1 minus E power minus RC by RC cancels out. What a charge after RC seconds? C into E minus 1 by E. Everyone knows E value. E value how much? E value 2.7. Please remember, the small things only changes our life. Please remember, E value how much? 2.7. Okay, remember, substitute here 2.7. 1 minus 1 by 2.7 means you will get exactly 0.63 into C. Means after one time constant, here RC is called here, product of resistance into capacitor is called here time constant. Time constant. How can you define the time constant? How can you define the time constant here, friends? Respond. The time taken when capacitor is under charging process, it is the time taken to accumulate 63.7% of maximum charge. How much charge? 63% of maximum charge. The time is called one time constant. 0.63 means in percentage you have to multiply with what? 100. That is the statement of the. So here after one time constant, what is the charge here? 0.63 into maximum charge. Understood, everyone? Now definitely you will ask me one doubt, sir. Then after t seconds, what is the current in the circuit, sir? Definitely you people will ask me. Tell me one plan. What we should do for finding current after t seconds? What I supposed to do? Tell me one plan. Tell me one plan. In transient state, what is the charge after t seconds? Respond. In transient state, what is the charge on the capacitor after t seconds? C into E into 1 minus E power minus T by tau. RC hereafter I will represent with what? Tau. Tau is nothing but a time constant. Now I want to find current after t seconds. You people tell me what I have to define. Current is nothing but what, ma? Increment in charge on capacitor by 1 second. Correct or not? Put Q value here. What do you get? Current equal to d by dt of Q value how much? C into E into 1 minus E power minus T by tau. C into E I will take outside. So I is equal to how much? C into E and for differentiation of 1 and d by dt of how much? E power minus T by tau. For differentiation of this constant, how much? Very good, 0. And what differentiation of E power something? Same only, na? So E power minus T by tau, but it should not stop. Again, this total term you have to differentiate as a multiple. Many students will skip this mistake. Now they will hear nicely only during the problem solving. They will ignore the step. What they got answer 100% will be there in option. Then finally biscuit will happen. Okay, that's what you should be very careful. Okay, clear on. Once again you have to differentiate. What differentiate? Differentiation of minus t by 2 how much? Minus 1 by 2 I have to constant outside. D small t by d small t how much? 1. Correct. Then minus into minus how much? Here minus into minus plus. So what are current after t seconds? C into E divided by tau value how much? R into C and in E power minus T by tau. CC cancels out. You know, any term representing how much? E by R is nothing but any term representing maximum current. For this kind of terms, always the constant term representing peak value or a maximum value. Understood? There also C into E is there, na? Check it. Instantaneous charge here. Where it is? Here, that charge after t second. There also C into E is called what here? Maximum charge or steady charge on the capacitor. So I can write here what is the current flowing in the circuit after t seconds. So current equal to how much here? E by R into how much? E power minus T by RC. This is the current after how much? T seconds. This is nothing but maximum current flowing in the circuit. So I is equal to how much here? I naught into E power minus T by R into C. This is representing rapid decrement. Rapid decrement means very quickly current will become 0. Okay. This is representing rapid decrement. Exponential means quickest decrement or rapid decrement. Means if you, by seeing the equation alone, the graphs also you have to select. As I told you in the beginning, current in the circuit I am plotting on y-axis, time I am plotting on x-axis. Initially, what is the current in the circuit? Initially, as I told you, current is maximum. Correct or not? Why? Capacitor is acting like a pure conductor. So maximum current it will be permitted. So when time equal to 0, current will be maximum. Maximum value how much here? E by R. Hereafter it will be rapidly decreasing like this. Should be very careful. If a question is giving, two options will be there. One is touching the x-axis, One is not touching the x-axis. Usually, first option it comes, it will touch definitely, and you people will select that only. You will not see third option or fourth option. Compulsory, this graph should not touch the x-axis. There is a meaning behind that. What is the meaning of not touching or parallel to the x-axis? After a very long time, then only the current become zero. That is the meaning. So it should not touch it. Okay. If you select any graph which is touched means over. So this is an exponential decrement. Here also, after one time constant, the current become exactly how much percentage? 37% of the maximum current. Here we got one more statement for the time constant. What is the statement of time constant? When capacitor is under the charging process, time taken to achieve 37% of the maximum current is called a time constant. Two statements. When charge is concerned, 63%. When current is concerned, 37% of the maximum current. Okay. Now, one question I will ask. Tell me what is the energy stored in the capacitor after t seconds? My question is, what is the energy stored in the capacitor after t seconds? What energy stored in capacitor formula? Q square by 2c. What is charge after t seconds? Very good. C into E into 1 minus e power minus t by RC up to, very good, whole square divided by 2c. This is the energy stored in the capacitor after t seconds. Tell me what is the voltage across the capacitor after t seconds? What is the voltage across capacitor after t seconds? I am telling. Q by C. Q value substitute. Okay. What is Q value? C into E and bracket start 1 minus e power minus t by RC whole divided by C. So what a voltage drop across capacitor? How much? E into 1 minus e power minus t by RC. Plot the graph. Respond everyone. Plot the graph between voltage drop across capacitor and voltage drop across the time taken. The exponential increment or decrement down. 1 minus e, if you are seeing exponential increment. So how will you get the graph? It will be like this only, na? Yes or no? Here also, after one time constant, what a voltage drop across capacitor? Just like that you have to tell. Very good. 0 point. Huh? Loudly re. Outside will talk nicely, na? 0.63 times. How much percentage? 63%. So 0.63 times to the maximum value. Correct or not? Two time constants also you can find. After two time constant, what you have to put? T value you have to put 2 into RC, and you can simplify and you can tell. After one time constant, how much voltage? One small question for you. You people find voltage drop across resistance after t seconds quickly. Voltage drop across resistance, I am asking you. Voltage drop across resistance, I am asking. Do paperwork. Tell me what is voltage drop across resistance after t seconds. You guide me, I will write. Tell me. I into R only na. Correct or not? What is current after t seconds? E by R into Shabbat, e power minus t by RC into R. R cancels out. What is voltage drop across resistance? E into e power minus t by RC. What is power dissipated across resistor after t seconds? What is power dissipated across resistor after t seconds? How much? I square into R. I value how much here? E by R into e power minus t by RC whole power into R. Okay? This is a complete analysis about the transient state during the charging of a capacitor. Okay? Clear? Now, once a capacitor is fully charged, what will happen? If you remove the cell, what will happen? Now, next one is discharging. Next one is what, friends? Discharging. I will take one fully charged capacitor. What will happen? I will remove the cell. I am taking one fully charged capacitor. What is your capacitor? Tell me. Left plate is your capacitor. You people tell me what is the maximum charge on this capacitor? Very good. Plus C into E. Be careful, this left plate only your capacitor. So I can write one point. Initially, what is charge on capacitor? Quickly. Maximum only na? Maximum. C into E here. And what about resistor? I will put one external resistance capital R and I will remove the cell. What will happen? Respond. What will happen? How charge will discharge? Like this or like this? Like this it will come. This point is very important. Charge is coming out of the capacitor temporarily. Capacitor is acting like a cell here. So initially the charge is maximum. What is the current here initially? Respond. Initially, what is the current in the circuit? I am asking you. C by T. Maximum. C by T. E by R. E by R. These are the initial conditions for the this one. Anyway, I am going to prove also. Understood? Okay. Why not C by T? Why? Why not C by T? T. T means what? Time. No. Tau. C into E by tau. And what logic you are explaining? Tell me. What is the initial current I am asking? Okay. Initially, maximum current will flow. After some time, why maximum current will flow? Initially, maximum charge will be discharged. As the time is growing, current will become zero. Anyway, I am going to prove. You will understand after the mathematical analysis. After t seconds. After t seconds means what the name of the state? This is initial state. What the name of the state? Very good. This is a transient state. I will assume during the discharging of capacitor, after t seconds, I will assume charge on this plus Q and current in the resistance equal to, let's say, I ampere. The loop is there now, so loop law I am going to write. the high to low, and here also high to low. The junction A and the junction B. So before applying loop law, how to walk? I'm walking from here A to B, then finally from B to A. So when I'm walking from A to B, what is the potential drop across capacitor? Very good. Minus small q by C. Then B to A I'm walking. Where to where? Low to high, no? Means plus I into capital R is equal to 0. So minus q by C plus what is the total current here? Total current in the circuit equal to loss of the charge by capacitor in 1 second only. Na? Current appear because of charge lost by capacitor. Lost means what? Minus dq. Minus dq by capital R equal to how much? 0. Not plus dq. Okay. So here time is variable and dq charge is variable. I am sending that side. So what will happen? Q by C is equal to how much? dq by dt into R. R I am sending this side and dt I am sending this side and q I am sending this side. Okay. So what do you get? Minus 1 by RC into dt, that equal to how much? 1 by q into dq, and integrate on either sides. When your observation started? 0 seconds. What is charge on the capacitor? Brains sometime we have to use. Maximum charge on the capacitor C into E. And after t seconds, what is charge here? Small q. So what is integration of 1 into dt? T. Put the limits. How much? T minus 0, and that equal to what? Integration of 1 by q? How much? Ln of q from C e to q. So minus T by RC equal to how much? Ln of q minus ln of C into E. So minus T by RC is equal to how much? What is ln of A minus ln of B? How much? Ln of q by C into E. How to remove ln? Base is there, na? So apply e power, and here also e power. Ln and e is getting cancelled out. So what do you get? Q by C is equal to how much here? E power minus T by RC. What is charge after t seconds? C into E power minus T by RC. This is a charge on the capacitor after how many seconds? After t seconds. Tell me, it is exponential increment or decrement? Whenever e power minus something is coming means exponential decrement. So how will you plot the graph? Like this only. Charge on y-axis and time on x-axis. How will you define the time constant? Respond. After one time constant, what is charge on this? 0.37 times of the maximum charge. I want to find current in the circuit after t seconds. This thing you have to do. Some task I will give right now. You people have to do it. What is the current in circuit after t seconds? First question. What is the current in the circuit after t seconds? First question. What is the voltage drop across resistor after t seconds? The second question. And what is the voltage drop across capacitor after t seconds? Third question. What is energy stored in the capacitor after t seconds? Plot a graph between I versus time. Plot graph between PR versus time. Plot graph between VC versus time. Plot graph between energy not required. Okay. Solve these problems. How will you find current equal to? Tell me one plan. How will you find current equal to? Minus dq by dt. I told many times. Current in the circuit contributed by loss of the charge. So you should not write plus dq by dt. Compulsory minus dq by dt. Put q value here. Where is q value? This value you substitute and tell me the answer. E by R only. How I equal to how much? Minus dq by dt. Q value how much here? C into E power minus T by RC. So C into E I will write outside. What is differentiation of E power? Same E power minus T by RC. And what differentiation of this complete term? Minus 1 by RC. And d small t by d small t, how much it will be? 1. Understood? So CC cancels out, minus into minus, plus what a current after t seconds? E by R into E power minus T by R. This is the current after how many seconds? T seconds. Minus into minus plus. Similarly, what is the voltage drop across resistance? Voltage drop across resistance, how much here? I into R. I value just now I found now. So E by R into E power minus T by RC into R. RR cancels out. What a voltage drop across resistance? E into E power minus T by RC. What a voltage drop across capacitor? Very good. Q by C. Q value how much? C into E power minus T by RC by C. CC cancels out. What a voltage drop across capacitor? E into E power minus T by RC. What energy stored in capacitor? Q square by 2C. Put Q value, you will get the answer. Graphs you know, no? This is representing which graph, ma? This is representing this graph only, exponential decrement. This also exponential decrement. This also how much? Exponential decrement will come. Okay. So this is the complete analysis of the, what do you say, RC circuit. But you can check no single problem also there. Today evening I will post the PDF. Okay. In your material, just check CR circuit, no problems are there. I will share in the evening or now immediately I will post. Work out that problem. Okay. Thank you. Bye.